In the last video, we looked at how we use electrolysis to purify copper. In this video, we'll look at how we can electroplate one metal with another metal. So, electrolysis, electroplating. So, as its name implies, electroplating means to put a thin layer of one metal onto another metal. So let's write that down. Put thin layer of one metal on another metal. So a couple of things you want to note are that at the anode, we must put the metal with which you wish to plate another metal. At the cathode, we put the metal to be plated, and our electrolyte has to be a solution of the plating metal. So I'm going to call the plating metal the thin layer of metal that you put on the other metal. So let's go ahead and set up our apparatus. Once again, we will have the beaker. And in this case, I'm wishing to plate a nickel spoon with a thin layer of silver to make it look nice and shiny. So on my cathode, I will put my nickel spoon. Just make sure it fills the beaker completely. And on the anode, I'll put a block of silver. And I would like to plate this nickel spoon with a thin layer of silver on it. I now connect them up to a cell. So at the positive end, I put the silver, and at the negative end, I put the spoon. So I have my anode here and my cathode. Just write anode, cathode. Just oops. So the nickel spoon. I have my silver bar here. The final thing we need is a solution that contains silver ions, since I would like to plate the nickel spoon with silver. So I will put, I'll use a solution of silver nitrate. So you could have used any other solution of silver sulfate, etc. But we'll choose to use silver nitrate in this case. So the aqueous silver nitrate will dissociate into silver ions and nitrate ions, while we also have water that's slightly dissociative, and that would dissociate into hydrogen and hydroxide ions. So we will now have the positive ions, the silver and the hydrogen ions, being attracted to the cathode. Oops, it's the cathode. It's the anode. So I have silver ions and hydrogen ions. I'm just drawing them on the cathode to show that they are attracted to the cathode. and I'll have the nitrate and hydroxide ions being attracted to the anode. So I will just draw them below the anode to show that they're attracted to the anode. Now the cell will supply electrons, and only either the silver or the hydrogen can receive these electrons. To determine which one, we will look at the cation series once again. So I have silver here and hydrogen here. Since silver is less reactive than hydrogen, it will be the one to be discharged. So I will circle silver to show that it is the species that will be discharged. Since the hydrogen is more reactive, it's gonna want to stay as an ion more than silver does, so silver gets discharged. At the anode, I have to choose between 3 different possibilities. In the first case, nitrate could be discharged, or I could have hydroxide being discharged. And the third thing that could happen is that the silver bar can dissolve. So which of these will happen to supply electrons back to the cell? So I need electrons to be supplied back to the cell, and only one of these can take place to supply that electron. First, let's compare nitrate and hydroxide. On the cation series, we see that nitrate is more reactive than hydroxide. Hence, nitrate is going to want to hang on to its electrons more than hydroxide does. So hydroxide will take precedence over nitrate when it comes to being discharged. So we can immediately eliminate nitrate. We next need to compare hydroxide and silver. But how do we do that? In this list, we have silver in the cation series and hydroxide in the anion series, but we had not learned how to compare these 2 series. The answer lies in a superset of this series called the standard electropotentials. We will not go into that in this video, but it turns out that silver has a greater tendency to discharge. Silver has a greater tendency to dissolve and give up electrons than for hydroxide to be discharged. So it is the silver that will dissolve and give up its electrons. So let's write the half equation for that. Silver solid will dissolve in the solution to form silver ions, and in the process give up 1 electron. So that is the reaction at the anode. And at the cathode, we have that silver ions will receive an electron from the cell and be discharged. So let's write an equation for that. Silver ions receiving electrons to form solid silver. Now where does this solid silver go? Well, it gets deposited on the silver spoon, and as time goes on, we get a thin layer of silver forming on the nickel spoon. So we had achieved what we set out to do. We wanted to put a thin layer of silver on the nickel spoon, and that's what we get. So for every silver ion that is deposited on the nickel spoon, a new silver ion is being dissolved from the anode to replenish that silver ion that was lost from the solution. Hence, as long as we have the supply of silver ions from the silver bar, the concentration of silver in the solution does not change. So this was the electroplating of a nickel spoon with silver. In the next video, we will look at how we can extract aluminum from its ore using electrolysis.